So today we'll be working on the review packet for Unit 6, and we're going to start on number 1, find the inverse of the following functions. So as you can see, number 1, the first part of number 1 is a logarithmic function. So every single time you find the inverse of a logarithmic function, you expect it to be what? An exponential. So if it's a logarithmic, remember to change it to exponential at the end. So the first step is to switch x and y. So instead of y, you can write x is equal to log base 6 of y. That's your first step. Then you have to write it as an exponential. So the base 6 to the power x will be equal to y, and that would be the inverse. Now let's move on to number 2. Number 2, as you can see, is an exponential, so you expect it to be a logarithmic inverse, so the inverse is going to be a logarithmic. But first you have to switch x and y, and then you change it to logarithmic. The base is 5, so you write log base 5 of x is equal to the exponent, which is y, and that is going to be your inverse. Now this is how you would do number 1 and 2. Now let's move on to the second part. In this question, they're asking you to change or use the change base formula to evaluate. But remember, you have to do numbers 6 through 9 without a calculator. So let's do 2 through 5. So what I'm going to do, I'm just going to give you the equation. You can plug this in your calculator. So basically, the change of base formula is to do the log of the argument divided by the log of the base, and you can plug this in your calculator and you'll find it's going to be 3.482. Now the second one, as you can see, you have an argument that is a fraction. So log of 25 divided by 2, that's the argument, divided by log of the base, which is 3, and the answer is going to be 2.300. Remember, you have to round and always give to the third decimal place. Now also this one's going to be log of the argument divided by the log of the base, and I guess you get the idea. Now let's move on to number 5. Remember, you can never have a log of a negative number or the log of a 0. So since they told you log of negative 1.5, you can directly tell me that this is undefined. You cannot have a log of a negative. You can only have a log of a positive number. Now let's move on to number 7. My pre-AP, I expected to be doing this without a calculator. My regular class, you can just plug it in your calculator. So log base 9 of 9, remember when the base and the argument are the same, the answer is going to be 1. A log of a 1 is always 0, so natural log of a 1 will be 0. Now let's move on to number 9. Now my pre-AP and regular, I expect you to be using the formulas that we have learned to do number 9. So every time you have a number in front of the log, you would take it as a power. So that's the first step you always need to do. Okay, now every time you have a plus, then it means that you have to multiply those two. So it would be log 3 squared would be a 9 times 4, and then it's the same base. So 9 times 4 is a 36. Now, my regular, you can plug this in your calculator. My pre-AP, you have to ask yourself 6. So you need to find the final answer. So 6 to the power what would give you 36? And the answer is 2. 6 to the power 2 is 36. So the answer of log 36 base 6 would be a 2. So the answer is a 2. Now let's move on to number 10 and 11. They're asking me to sketch the following on the same graph. Be sure to include both asymptotes drawn with dashed lines, include the line y equals x, and determine if the equations are inverses. Be accurate in your drawing by using key points. Now, my pre-AP, I expect you to show me work. My regular class, you can just plug this in y equals and go to second table to get the points. Now, Remember, every time you have a log, then you have a vertical asymptote. So you look at the inside of your log. So then the vertical asymptote would be x is equal to 3. So let's draw this. I'm going to use the red for the log so you can tell them apart. So x equals 3 is going to be my vertical asymptote. Okay, now again, my regular, just plug it in your calculator and get the points, but my pre-AP you have to show me the work. So pick up points that will help you work. So for example, if I take x to be 4, then you have log of 4 minus 3, which is a log of 1, and log of 1 is equal to 0. So the first point is 4, 0. Then pick a point that would make this equal to the base. The base is 10. So x can be 13. So if you plug in 13, it would be log of 13 minus 3, which is a 10. And log 10, since you know if there's no base, then the base is 10, the answer is going to be 1. So the second point is 13, 1. So my academic, just plug it in your calculator and get points that is easy for you to draw. So 4, 0 will be here. 13, 1 would be somewhere over here. Now remember, the calculator will not give you the whole graph, so you need to know that it's going to extend down and would go through those. So that would be my graph of the log x minus 3. Now remember, so as you can see this, how did it shift? It shifted 3 steps to the right. Keep that in mind. Now I'm going to use the blue for my exponential. Now exponential, so there is a horizontal asymptote, which is y equals 3, and I'm going to draw that in blue. Y equals 3. Now again, my academic, just plug it in your calculator. My pre-AP, just pick points. So if x is 0, so 10 to the power 0 plus 3. 10 to the power 0 is 1 plus 3, which is a 4. So the first point is 0, 4. And if you choose 1, then plug it in your calculator in x. So 10 to the power 1 is 10 plus 3, which is 13. So the other point is 113. So let's draw that. 113 would be somewhere over here. And the other one is 0.4. So if you try to graph it on the calculator, it will not give you the whole thing. Remember that it extends in both directions. Now we have to decide whether, so I need to draw the y equals x1. We have to decide whether these are inverse or not. So let's look at this. Now the asymptote is x equals 3. Here it's y equals 3, remember? So this is, it could be, now let's look at the points, 4, 0 and 0, 4. So as you can see, x and y are switched. 13, 1, 1, 13, they're switched. Again, this is going 3 steps to the right, and this is going to go 3 steps up. So all this show me that those two functions are inverse to each other. And if you look at the graph, you'll see that it is like symmetrical to each other, as you can see. They are symmetrical to each other with respect to y equals x. So yes, they are inverse. Now this is it for the first page. Now let's move on to the second page. So let's start with the first part, holiday season, and then we have years since 2002. So the number 0 or 0 years count for counting from 2002, 2003, 2004, and so on. So they want exponential model. To do that, you have to go to Stat, Edit, and enter the numbers in L1, so the X in L1. And then you go to L2 and you enter the Y values. 300 and 850. So the values are there. Now they said that this is an exponential function. So you can go to Stat and then to Calc, and you go all the way up or down until you get to exponential regression. You keep pressing enter and you get until you get the equation. Remember, you always round to the third one. So let's do that. So then the equation is going to be 68.239. So if you round up, it's going to be 240 times 3.688. So 3.688 to the power x, and that's going to be my exponential function or exponential equation. Now use the model to predict sales in 3 years. It means x is equal to 3. So y equals to everything that you see to the power 3. Now you can enter this in your calculator as it is and solve it. So you can go in here and type in the numbers and you get the final answer, or you can go to y equals and plug in the regression equation over here. So how you do that, you go to vars number 5, which is statistics, you go to equation EQ, and then number 1, which is the regression equation, and as you can see, it will type the whole thing for you. Remember that you have to pay attention. Some calculators do not copy the x. It might leave it empty and you have to type in the x. Now by doing that, it means that you typed in your equation over here. Now you can go to second table and you look that when x equals 3, the y is 3422.5. But remember that this is in thousands. So you can write in parentheses thousands, or what you can do is you can move the decimal 3 times to the right. And then you can tell me that this is like 32,000 or 322,500. So you can do any of that, but remember to look at the multiple choice to the side. Now let's move on to the second part. Now over here in this problem, they're asking you to do a couple of things together. They want you to describe the transformation, say what the end behavior is, the domain and range, and then find the inverse. So I'm going to start with the first one. This is a log, so it has a vertical asymptote. Nothing is with the x, so the vertical asymptote is going to be x equals to 0. Now once you know what the asymptote is, you can directly know what the domain. The domain is going to be from 0 to infinity, and the range is going to be always all real numbers. So the domain is going to be from the asymptote all the way to infinity. Once you know your domain and range, the end behavior is going to be easy to figure out. So as x tends to 0, y tends to negative infinity, so this has to be 0 and this has to be negative infinity. And as x tends to infinity, y tends to infinity, so this is going to be infinity. Because if you draw this, it's going to look like this. So as you can see, as x approaches the 0, it means the y-axis, the y is going down to negative infinity. And as x approaches the right side all the way to plus infinity, also y is going to be plus infinity. Now how's the transformation? This one tells you that it's going 1 up. Now let's look at how to find the inverse. The first thing that you do is that you switch the x and the y. You isolate the log, so subtract 1. X minus 1 is equal to log base 5 of y. Let me make some space to write. Okay, once you do that, remember the inverse of n logarithm, or a logarithm, is going to be an exponential, so 5 to the power of that is going to be the inside of the log, which is y, and this is going to be the inverse. You can write f of negative 1 is equal to 5 to the power x minus 1. Now let's move on. I'm not going to do all of those. I'm going to just do the exponential one, but remember that here x equals negative 1 would be your vertical asymptote, and then everything will be changed accordingly. Now let's move on to the exponential one. Here it shows you every time it's an exponential, so you have a horizontal asymptote. So the domain will always be negative infinity to infinity, but the range is going to be from the asymptote to infinity, so it's opposite to the logarithm one. Domain, or the end behavior, as x tends to negative infinity, y tends to negative 1, and as x tends to infinity, y tends to infinity. Now, how is this moving? This is going to be moving 1 down. Now, I don't think I have time to do the inverse, but the second video will